Hey everybody, this is Larry. This is day 31st of the Leetcode Day Challenge. Hit the like button, subscribe button, join me on Discord. Let me know what you think about this one. Today I ran another 7 miles, 8 miles, something like that. I was going to go more, but honestly, I was not ready for it in the sense that I needed to use the restroom, and I was like, just hold it in and get back to your apartment and use your own thing. And that's basically what I did, but it was a little bit short. It's okay though. Better a little bit short than and no accidents, you know. But yeah, hope everyone's having a great weekend or had a great weekend, and you know the month is. I guess this is the last day of the month, right? Yeah. Ready for prom, so always in exciting times. Hope everyone kind of had a good month. The markets are crazy, right? Let me know in the comments if you pay attention to the stock markets. I don't know. I'm just been on my mind the last couple of things. But yeah, my eyes are so yeah. I gotta stop rubbing it. So every time you see me rub it, let me know in the comments because I'm a little bit allergic. So I have trouble even breathing from time to time, so my apologies if these videos are a little bit and I'm probably rushing a little bit because I'm trying to get back to washing my face or whatever, because I don't know, allergies this time of year. It is what it is. Okay, let's take a look at today's problem. We have 2551, put marbles in bags. All right, let's do it. You have k bags. You're given a 0 indexed integer array weights, where weights of I is the weight of the ith marble. You're also given the integer k. To write the marbles into k bags according to the following rules. No bag is empty. Okay. If the ith marble and the jth marble are in a bag, then all marbles with an index between I and j should also be in that bag. So okay, so if you pick I and j, then has everything in the middle. If a bag consists of all the marbles from I to j inclusively, then the cost of the rate is weights of I plus weights of j. The score after distributing the marbles is the sum of the cost of all the k marbles. Return the difference between the max and min. Okay. So I guess this is like a twofer in the sense that there are two problems, right? And we have to, and all the bags have to be divided. Okay, and you have k. Okay, so I don't know. So well, there are two problems, right? One is the min and one's the max. We'll see if we can kind of just figure out one of them, right? Okay. What is there to think? And I and j could be equal to j. Okay, right? Maybe. Let's see. Yeah. Okay. Okay. So, all right. Let's pick one. I don't know. I was just trying to feel things out, and I don't really know that I feel anything. I'm dead inside apparently. The way I phrased that one. But no. But. Okay. Okay, so what is the maximum score, right? The maximum score would be that you have as many, or you have the biggest numbers possible, and the smallest, and minimum would be the smallest score possible. Okay, I'm just saying very dumb things, but okay. So here, let me think about how to divide it up. I mean, I have the idea. It's going to be greedy, right? And the greedy is just by exchange argument, in the sense that, okay, you have, instead of, I think one way that I would think about it, okay, maybe not this, but the initial way that I would think about it is that, okay, well, first of all, you have to choose, I mean, it's not a cut, but you have a cut on the left and all the way to the right, because they're going to be the boundaries. So then now you're choosing, with k is equal to 2, that means you have one cut, and that means you could choose one cut anywhere in between, right? And what does it mean to be in between? Let me write it on the bottom. What does it mean to be in between? Well, that just means that if you cut it here, then you have 1 and 3. Here you have 3 and 5, right? And here you have 5 and 1, right? So as a result, and keep in mind that these cuts are basically independent, right? Meaning if here you have k is equal to 2, so you have one cut. But let's say you have another cut, this one, and then you could do this one, right? So what that means is that, I mean, of course, you can pick the same cut again, but they're independent in that your choice of a cut doesn't influence the value of the other cuts as you go, right? So that leads itself to a very honestly basic sorting algorithm, right? Because it's just greedy. Because it's an easy exchange principle argument that exchange argument that I'm not going to go even rough going to do, right? Because here it's like, okay, you cut for 8 or you cut for 6. Well, I mean, always cut for 8, right? And it's 8 because it's 3 plus 5. And that's really it for this problem for the max, right? Can you do the same thing for min? That's the one thing I think so, right? Because min, I don't think there's any different. You just do the smallest. I thought there might be some things where it may be a little bit different, but I don't think so, right? Because also the exchange argument, right? Or if you want to think about it the other way, or another way, not the other way, is that you could just convert, you can multiply all the numbers by -1 and then choose the max, right? And there's no, because it's just sum. There's nothing that changes it, right? So as a result, min and max is the same idea. So basically this becomes a top k problem, right? And top k, of course, you can use a heap. And yeah, so we could do that. So let's do it, right? There are a couple of ways you can write this. Min heap and max heap are both kind of a little bit awkward in Python, or it's awkward to parameterize it. I'm saying it wrong, right? Meaning that in other languages you could pass in a function or something like a greater than or less than in Python or in C++. Which allows you to kind of be contained, like your container will do all the work for you and stuff. But in Python it's a little bit awkward, but that's okay. It's just a little bit more code, especially for this problem. So yeah, so the first thing we want to do is just we go, okay, so maybe for I just call them XY in general, right? So actually, what should I usually, or in the past I usually write this way, but now I've been kind of been more trying to write it this way. Oops, maybe correctly though. Right, to get adjacent numbers, right? And then now we want to put x plus y into a heap, right? So maybe we have a heap small, and here we just want to keep the smallest k items, right? Or k minus 1 in this case, but smallest k in general, and then maybe largest k items, right? So k large maybe, right? And this is the value, right? Yeah, and then for small, well, we want to keep the small one, so we want to remove the largest number, right? So and so as a result, to remove the largest number, heap by in Python is going to be whatchamacallit, stop rubbing. It's a max heap, right? Oh, sorry, it's a min heap, so we have to convert it to a max heap by doing a negative. And that's really it. And we'll do the same for the x large, but of course it's just a regular min heap because you want to remove the smallest number, right? And then, yeah, and then maybe just like a while length of h small is greater than k minus 1, right? Because you remember that k is the number of sections, but it also is the number of cuts is k minus 1. Also, I'm going to forget this, but if I do, I'm going to remark that I do know that you have to add in the borders once more, but maybe I'll forget because I've been kind of silly lately, to say the least. Say the same for h large, even though, it should only happen once, but I don't know. It's not that expensive. And yeah, and then now we can just return. Well, actually, I was going to say, I was going to remember about the borders, but keeping in mind that the borders, they're going to be both in the large and small. So if you just subtract them out, they cancel each other out. So actually, I lied. We don't need to do that. So then now we have to get the h large minus some of h small. But keeping in mind that h small is all negative values, so we can actually just invert this by, I don't know, maybe I'll write it this way. I know that in double negative, I know how double negatives work, but it is a little bit more what I wanted to do, right? But like we want to get the delta, but we also want to multiply this by -1. So that's basically it, hopefully. And yes, Apparently it's a little bit slow. Maybe that's surprising. I don't know. But faster than my previous one. What did I do previously? Okay, so previously I just sort, which is also fine, I suppose, or obviously correct, if not optimal. Also, you sorting last time, huh? Yeah, okay. I mean, yeah. Today, apparently, I did with K heap, top K heap, and that's it. What's the complexity, right? Well, for each pair of numbers, which they're only because they're adjacent pairs, the O of n number of pairs, we're going to do a log K algorithm, or sorry, log K operation step, right? So it's going to be n log K, and that's it, really. This is very... and this total is just O of K, right? Because each of these things have K items. Yeah, I don't really have much more to add to this one. I mean, this is a pretty standard application of top K. I think the tricky thing, obviously, is seeing it in the way in which you have to divide the array, right? But yeah. Anyway, that is all I have for this one. That's all I have for today. Couldn't keep it short. Yeah, thanks for watching, and let me know what you think. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.